Welcome to my first tutorial. This series is going to be on how to use Blender without any modeling. This tutorial is meant more for those who may be coming from another platform to get used to it first, maybe Source Filmmaker, or never even used any 3D modeling software ever. You can do everything you want in Blender almost without even ever modeling. Maybe modeling is not a skill you want to do. Maybe you're on a team and you're the you set up the field to get pictures, animation started. Maybe you're the animations guy. Someone will send you the characters to animate, pre-set up and everything. But let's get on with it. This is the tutorial for Blender 2.8. It technically is in beta, but at the current moment it's running pretty well for most people. Alright, so when you download the Blender 2.8, link in the description, and you open up the main file, you'll be presented with this giant mess of files. And the one you want to find is blender.exe. This will open up the actual application, and you'll be presented with this screen. Except you won't see all your recent files since you've never had any yet. So let's get rid of this by just left clicking right back here. To start off, we're just going to go through the settings, making sure everything is working how you want it. Because when you start off with Blender, it's not going to have the settings you want. And if you're on a 4K screen, I'll show you how you can fix the icon sizes and lettering so it fits well without shrinking too much. So we're going to go to Edit, Preferences, Interface, Resolution Scale. This is how we're going to change how big everything is. You can just type the number you want, slide it, manually click. 1.0 would be pretty much the size you'd expect on a 1080 screen. A little translation for anyone who doesn't natively speak English. Blender has lots of support for many other languages, which is really nice. However, I don't need any. And you can set it depending on interface, tooltips, and new data, whatever that may be. Alright, so if you're on a laptop by chance, you're probably going to want to turn on Emulate Middle Mouse, because on your trackpad, you're not really going to have that. If you alt left click with your pad, you'll pretty much get what is the middle mouse. If you have a mouse already, you're one step ahead of everything. Key map, here we are. So if you're coming from Blender 2.79, you may want to switch select with back to right. As with Blender 2.8, it standardizes with the rest of other softwares using left click to select everything. And right click brings up a menu. And again, if you're coming from Blender 2.79, spacebar has been remapped to place, so you may want to change it back to search. If you don't, you're going to have to use the tilde key, which is right next to the one and above the tab on the normal QWERTY keyboard. For me, I keep it on search. I don't use animation enough myself to need it for play and pause. This is a big one here. So often when you start with Blender 2.8, it's not going to auto detect your hardware for what it needs to put in. It's going to find it, but it won't put anything in. Now if you're using a CPU only, you know, an Intel or AMD with built-in internal graphics, you're pretty much going to keep with none or OpenCL. Right, if you're using a NVIDIA graphics card, you're going to select CUDA and make sure your graphics card is checked. And if you're using a AMD graphics card, you're going to want to select OpenCL. OpenCL should pretty much work with any graphics card that's not NVIDIA. And you'll notice here that there's also a check mark for the CPU. You can click that, and the CPU will also do some of the rendering processes for you too. If you have a beefy CPU, this is going to be helpful. If not, it's best to keep it unchecked. If you leave it on and your processor is not that powerful, it will actually take more time to complete the process of rendering. You can set your memory limits how you want, yada yada. Now switching over to add-ons. This you can kind of think of as plugins, mods, that sort of thing. You can add them in by installing from zip files, which as we can see from mine, I have all these. You would simply select the zip file you want and click install add-on from file. And when you do that, you'll be able to search for it, or it should actually come right up to click on it. It should look like that when you install. And you just click the checkbox to add it in. You don't have to add denoise. This add-on is one I personally use to replace the built-in denoiser in Blender. It's made for any GPU that's, I believe, the GTX 960 or 1060 and newer, only from NVIDIA. It uses AI to denoise and it comes out much clearer, but if you have an AMD graphics card that you're rendering with, or the base Intel processor or AMD processor, it's not going to work at all. But there is one add-on that I'm going to suggest you turn on, and that is Auto Tile Size. This should be installed by default in the current versions of Blender 2.8. This add-on helps your rendering time speeds. It will make it faster indefinitely, but not blazing fast, just optimized fast. It can turn a 5-minute render down to 3 minutes from optimization, but we'll get to that later. That pretty much wraps up the settings. Now, your interface is very dynamic in how you want to use it. This is the default interface that you'll find when booting up Blender, unless you've preset a new default save file. But anyways, up at the top you'll notice there's these tabs along the menu. In these tabs you'll find that it adjusts how your layout appears. And this shows how vastly dynamic all of this is. You can set up how you want your layout perfectly. And that's one thing that is just wonderful about Blender. While you can also have extra windows with all these layout pieces in it, you can set up exactly how you want the layout with simply dragging and choosing the layout. For recapping what I just did there, if you bring your mouse right up to a corner between any boxes, you can drag up, left, right, up, down, and you'll see this little box here. This should have the icon of the screen you're in. It will duplicate from one of the two screens that was in the corner. For example, it duplicated the outliner. If we click on this, it'll bring us the options we have for different windows inside the screen. For now, we don't actually need this. So to close it, we click on this little corner between it all. So we push it into the one we want to get rid of, and it gets rid of it. And these are all resizable too. Alright, so back to the whole screen. This right here is the 3D viewer, or the 3D viewport as it's called. Your entire scene is set up inside this whole space, and that includes the camera, lighting, models, anything not hidden. You can view around this area by using your middle mouse click, holding down, and just moving your mouse around. And if you want to zoom in and out, you can push the middle mouse forward and backwards. To pan around, you're going to hold the shift and middle mouse down and move your mouse. That pretty much sounds moving around the scene. Once you got that, you can get anywhere. Alright, so how do we interact with the scene? To interact with the scene, you're going to use the left mouse if you didn't change it back to right mouse. If you change it to right mouse, you're going to use the right mouse button, obviously. But the same still applies using left and right. Now, if you click on an object, it will highlight it with left mouse or right mouse. And if you click and drag, you can select multiple objects at once. Clicking outside of the objects will deselect everything. You'll find these arrows pop up on the X, Y, and Z axes. And there's also these panels. These arrows allow you to move across the axes, while the panels will move it on every axis except for the one that you highlighted. So this red one, we're going to move it on every axis except for X. This blue one, we're going to move it across every axis except for Z. Now we're going to move it up one. So we're going to click on this. I'll make sure to explicitly say every command as well as I can. So going back to moving the object, I want to get it just on top of these lines. I'm going to hold the Control key, click the Z axis, and move it up. You'll notice that's moving in really lagging like way. But what's actually happening is it's locking to the nearest one unit. Alright, so now we want to get towards rendering this cube. It's not a very pretty scene, but it will work. Up here on the right hand side, you'll see there's a series of circles. These are your render views. If you click on them, you can get your different renders. Now I'm in cycles mode right now, so you'll see it's very laggy, things aren't looking right. This is because it's using ray tracing to render. I'll get to that in a bit. For now, we're going to click on the second to last one, the look depth mode. This uses a simplified version of Eevee's rendering, which I'll get to that later too, to give you a look into what's happening in your scene. So we want to see what's actually going on in our scene. We have this little thing here. This is a light. It's when we move it around, it's not really affecting our object. That seems weird, right? That's because in this view mode, we have no light sourcing. So what we need to do is go over to our properties panel, go up to this little TV looking icon, camera, click it, it's called render. Click the render engine and select Eevee. Eevee is Blender's new render engine. It uses game methods to produce images, really. Images, animations. It's pretty fast, but it's not as realistic as Cycles can be. Eevee uses rasterization where Cycles uses ray tracing. These are entirely two different methods. However, thanks to how well they built Blender 2.8, we can use Eevee for setting up a scene, and if it's good enough for you there, you can call it good, take the final render picture, animation, and call it good. But if you wanted more realistic, you'd want to use the Cycles. So for now, we're going to use Eevee, just so we can set up our image and get what we want. Now if we go up here to our different view methods of the viewport, we're going to cycle over to the rendered view. In this view, you can actually see the light moving around. It's affecting the object, which is good. Now if you don't have a very beefy graphics card or internal graphics card, maybe it's several years old, it may not work as well for you and you may have to wait to do that, manually checking it. But for now we're going to use this to set up our scene. I don't like this light, so I'm going to right click and delete. Now to add a new object, we can go up here to, on the left hand side, click add, light, and I'm going to use sun. From here, I'm going to move it using the key commands. I'm going to use G to initialize the move command itself, and using Z, X, and Y, we can move accordingly on those axes. So I'm going to press Z, move it up, G to move, Y for the Y axis, G to move, X for the X axis, and we're going to move it up a bit more. Alright, so you'll notice that as we moved it, that light did not affect the block at all. The other light did, which is weird, right? So how the sun works in Blender is it's a form of global illumination. It affects everything that comes from the direction that it is pointing with this line. And we can control that point by either rotating, which we can do by clicking the rotate button and moving it along the axes that we want it. You'll notice that's all of a sudden now affecting the actual light position. Z, of course, isn't doing anything since we're moving it across the Z axis with it's a straight line. But now we move it across the Y and X, we get some lighting action. And we can move it across both of these accordingly. I want to get that corner right here to show up, so we're going to bring this over more, and we're going to bring the X right around there. And we can also again do these using the exact same keys as the move tool on the keyboard, however using R to initiate rotate, and then Z for moving on the Z axis, X for moving on the X axis, and Y for moving on the Y axis. Alright, so now we got our light how we want it. It looks good, but it's not bright enough. So if we go over here, although it's called object data, it's really light, this little green light bulb. We can adjust how the sun is working. This angle, this should determine how much shadow is given, how soft and sharp it is, if any. Specular we can ignore for now. What we need to worry about is strength and color. I'm going to up the strength a bit and give it a bit more of a yellowish hue. That's good enough for me. So now we want to take a picture of it. This picture is called rendering. It takes a snapshot of what's happening in the 3D world and generates a 2D picture. So how do we do that? Let's just delete this camera for now and do the process from scratch. Using the 3D cursor tool over here, we can select a surface. This point is a special point of origin. It can be used widely all over Blender, but its most noticeable use is whenever you add a new object. So for example, if we go down to camera, it will add it right there. Now since we're going to go back to the select box so we don't actually move the cursor again, even though we don't need it anymore. The camera is already selected, so I'm going to select G and Z to move it up. And I'm going to press G, X to move it backwards. Now, what view is our camera getting? That's the question. It's getting that view. There we go, that view. That's not very easy to see what it's doing, is it? So if we go over to our number pad, this is not going to work the same as the numbers across the top of your keyboard. But on the number pad, if we press 0, we will go right to the view of exactly what the camera is saying. Inside this normal view here, this is what will render when you click to render. Outside of it, in this dark gray box, this will not show. None of it. So now, if you want to get a close-up view to hide more of these gray areas, you can use your middle mouse to zoom in and out by scrolling. Now you notice that the camera is still selected and we're inside the camera. Now a nice trick to help setting up your render shot is that you can move the camera while you're inside of it. And we're going to use just key commands in this. So while the camera is still selected, you can tell by the highlight here. So when we unselect it, it becomes this dashed line, and we reselect it, it becomes this highlighted line. Now when we press G, and if we don't initiate any X, Y, or Z, you'll be able to get free motion across the axes it's facing. So it's not moving forward or backwards, just left, right, up, and down. Now if we select the axes we want, Z, you notice we're going up and down. Now a neat trick with the key commands of using the move and rotate tool is you can instantly use the normals. A normal is the direction a face is facing. So if we press Z again, we're now moving across the direction that the camera is facing exactly. So as we move the mouse backwards, everything gets farther away. As we move it forwards, everything gets closer. Now if you want to get out of this view to see what's actually going on, you can just hold down on the mouse and move around, orbit around. So now I'll show you again exactly what was happening just a second ago. Press G, Z to go into world Z axis, and then Z to go into the normal Z axis. You'll notice that the blue line is now going across through the camera right out the front face. And if we move across this normal Z axis, it's moving forward and backwards. So we're going to go back into our camera, pressing 0 on the number pad key. And we're going to use the rotate and move tools to move how we want the cube to look in our final render. So I'm going to rotate it on the Z axis, the world Z axis. I'm going to now move it across the normal X axis. I want to get 3 sides in the shot. I'm going to rotate it across the world Z axis, only pressing Z once. Move it just up a little. Move it in a bit. Up a little more. In a little bit. This is a tedious process, but there's a way we can get around this very quickly. So there's a special command where you can move the camera to pan in, zooming in and moving the camera left, right, up, and down to fit the camera to view the object or objects selected. And to do this, we're going to press the tilde key, or if you changed it, spacebar key, and type fit. And just by typing fit, it pops up right there in the very first box right there. Camera fit frame to selected. You can either click it or press enter and it will do the action. So now it's perfectly centered on the object, on this cube. So now I want to, oops. Now I was about to move it and this box was selected. So I'm going to reselect the camera because I want to move the camera, not the box. Press G, Z twice to zoom out of the object. And I think that's pretty close to good. So now I don't like the color that this box is. There's a lot of cases when you're using Blender without modeling where you can actually modify how things look. And to do that, that's in this material box right here. A lot of this is not going to make much sense, and I'm going to go over that in a much later episode. For now, you just need to worry about the base color. Since we have a yellow light, I want a bit of a bluish purple. Yeah, that looks like a nice blue. I'm going to go with that. You can use any color you want. Now, The final step here is to produce our image. First, I'm going to test it with the Eevee renderer. I have a beefy enough graphics card that I can easily do cycles rendering, and this won't even take much time to do. So, to render, you want to make sure that the render engine in the render tab is selected on Eevee. You're going to go up to the render menu and select render image. And you'll see you'll get a nice clean image with the gray background, the cube color you want, with the lighting you want, at the angle you wanted. Pretty much an exact view of what's right there. Pretty one-to-one, right? So that's good and all, but I don't like this light. And it's just not bright enough. So we'll bring it up to 3. No. 6. And we're going to make it a bit more there. Alright, so now if you want to render again quicker, you can actually press the F12 key on your keyboard. Now when you zoom in, you'll notice that there's a lot of these lines. It's pretty crisp now, but in bigger images with more detail, they'll get fuzzier. And you'll actually get a difference from these controls right here, the render and viewport. What these are is the number of times it's going to render the frame and average out the individual pixels between each frame. Right now, by default, it's set to 32 samples per pixel for the render and 16 samples for the viewport. Now you can actually use this to your advantage if you're testing to see how well it looks, as right now we're in the render preview mode, which pretty much shows the render using previous settings. And if your computer is not running as well, you can maybe bring it down to 2 and hit enter. And you notice that I actually got less sharp over here. There's more defined pixels. So we'll render the image so we can see it closer up using that exact same setting. So you'll see it's sharper, more pixels viewed. There's less shading right here. So now when we increase this to say 64 samples per pixel, when we zoom in, you get a lot more blending with all the pixels, which makes a sharper, clear image. When you have things like, say maybe a thin power pole line, you'll get a lot of that there. In video games, they use anti-aliasing to fix this problem. It goes after the image is rendered, it will smooth things out afterwards at a loss of detail. Using this in Blender, you do not lose any detail. You in fact gain more detail in the end. Now we're just going to keep that at 64, but bring this back up to 16 because mine can handle that. Maybe this just isn't realistic enough for you. It's a boring flat cube. So what we're going to do is switch from Eevee to cycles. And you'll notice right away the render preview mode, it got fuzzy. It's still fuzzy. It got a little clearer, but it's still pretty fuzzy. And that's because we're now using ray tracing to produce all the graphics. Now, you may be able to hear, but my computer's spinning up, so to soften that, I'm going to switch back to the look dev view. This does not actually emulate light still, but that's okay. And to kind of take advantage of the ability of cycles to make it look a little more realistic, I'm going to adjust some of these settings. You can follow along too if you want. So now by default, this is the material you're going to get. This little preview panel shows what material is going to come out. I want a more metallic material. I don't want any bit of specular. We're going to reduce the roughness down. And that's good enough. So now, to render Alright, so I forgot to mention, but Cycles isn't very user-friendly sometimes. It doesn't like to automate things. So we need to click CPU and GPU compute. This is only if you have an actual graphics card. If you don't, this option will not even show. But this will actually use your graphics card to render everything. If you don't, it's going to use your individual CPU cores to render, not even the internal CPU graphics card. So now anyways, if we go down to performance, you'll notice that auto tile size is blue and highlighted right here. This is because earlier we turned on auto tile size. That affects these two numbers right here. Because ray tracing is such an intensive process, instead of rendering the entire screen at once, it puts it into tiny little chunks and renders just those little bits. And it keeps doing that until the entire field is filled and the entire image is created. And these tile sizes are the pixels wide and height. If you make them too small, you will get really slow results, and if you make it too big, you'll also get slow results. So Blender has this nice add-on called Auto Tile Size, which will create it for the best option that you have selected. So for my GPU, which is an RTX 2060, that happens to be 240 by 216. If we unclick this, we can easily change this ourselves, say maybe 32 by 32. The default that was set in there when the CPU was there. But when we click it again, you'll notice it fixes it for us. This is a must-use tool, and after that, you really don't ever have to touch Performance panel again. But we need to go into our Samples panel. Now, just like Eevee, Cycles uses render and viewport sampling. So by default, it was set to 128 ray traces per pixel for render and 32 ray traces per pixel in the preview, which is the viewport right here, the preview mode, when we click this button. It's going to take a second because we made changes to the material that didn't exist beforehand, which would be the metalness. You'll notice right up here, it actually tells you what's going on when there's slow times like this. When it does not tell you what is going on, then it is taking time to do a process that you had it set up. You may not know what it is, but this process can sometimes include physics or rendering. You just don't have the render screen showing. But yeah, we will just give it a minute to show up and I'll get back to you. Alright, so you now notice that it's finally showing our render again. However, it's taking time to do this. You'll notice that's going sample by sample, but it's actually tracing the entire image here at once. Not only that, but it's also tracing out here in the gray border too. So because it rendered that frame and image and we haven't moved anything, if we say rotate our camera, which will change the view we're looking at everything, say rotate Z, you'll notice right away, even just clicking it, it restarted the process. And again right there. And you can actually see what happens as we increase the number of samples per pixel. It keeps getting clearer, there's less black, but because Cycle works a bit differently, you'll notice that there's no shininess that we expect. So we're going to increase our strength to double. That was not enough. Double that again. Ooh, that was way too high. I'm pretty lazy, so I kind of double it sometimes. That's probably way too much, but good enough. So now we got the box how we want it. We got our camera how we want it. I'm going to switch right back here to the looked up mode. This is so the GPU is not constantly ray tracing again, but instead using the quick rasterization methods. So now I'm going to hit, well, first I'm going to change this down so you can actually see the process of it rendering. Say going to do 32, the same amount that we saw in here, we should see in the final render. So when we hit F12 to render, this part may take a while at first for you. What it's doing right now is loading the kernels, which tells pretty much how to render everything. Compiling render kernels. Now we have other information up here we can look at too. The time it took for the last image to render. Oh, here we go. So now that we're rendering, you can see it's going box by box, rendering each part individually. And as it does that, it completes it in a fast, timely manner. But to kind of show you what happens if your tiling is not all that great, I'm going to disable auto tile size and bring this down to 16 by 16 and hit render again. So now if we look up here, the last image took 31 seconds. This was with auto tiling. And currently we're already 1/3 of the way done, and it expects to be about 10 minutes till it actually finishes. This is how the optimization of auto tile size actually makes your job quicker for rendering. It doesn't actually increase performance, but just optimizes how it does the rendering. Now, I'm not going to sit here and watch all this since we already did it before and we know we can do it fast. So I'm going to hit escape, and this will stop the rendering process. Switch auto tile size on back, re-render, sit for the 31 seconds it takes. Now I'm going to take a second and actually zoom in here. Now you'll notice it's actually a bit more blurred line here. Now due to the ray tracing, you'll notice it's a lot more blurred here, less pixelated looking. Everything's much cleaner. We got a little bit of brightness over here from the metalness of the box. And now that we actually rendered it, how do we get this image out of here? Now to actually get this image out of here, we're going to select image, save as, and choose where you want to put it. I'm not going to actually save this, but when you find the place you want to save it at, say maybe desktop, you will give it its name and click save as image, and that's it. Now that pretty much sums up this entire first tutorial. I've shown you how to go through the settings to make sure your Blender's set up right, how to go through the user interface including editing it and switching between preset modes, how to move objects around, move the camera around, and how to actually render images in both the cycles and Eevee, along with setting those up to render. Next time I'll show you how to actually import objects so you don't have to model them yourself, set them around the scene properly, making sure they're flush on surfaces, and some more camera moving, maybe some light setup. So thank you for watching. If you have any questions, comments, just leave them down in the comments. If there's something you want to learn or having trouble with, I'll try and reach that into another video if I can't respond in the comment itself. Share it with any friends who may want to get into Blender. Thanks to its newer Eevee rendering in Blender 2.8, a lot lower end hardware can actually do both the modeling and non-modeling methods of rendering in Blender. Thank you and goodbye.